Hello and welcome. So we're going to be graphing a hyperbola and finding all of its related information. All right, so let's get right into it. So first off, got to find the direction or the orientation of your hyperbola. So looking at this one, how we can tell that is we essentially look at what's positive. You'll notice that you have a y squared term positive. That means that you have a vertically oriented hyperbola. If we had seen our x squared term, right, if we had saw that before the subtraction sign, if that was the positive term, it would be a horizontal hyperbola, right? But because our y squared is before the negative, it's positive. That means that you have a vertical orientation, and you're good to start going on this one. Okay, so first off, so you have your vertical hyperbola. Again, graph it a little bigger on the side, and you know that between them you have your center, right? And your center is going to be h comma k. All right. Your vertices, you'll notice, are going to be the turning points of your hyperbola there. So that's going to be, you notice, only a difference in y. So your h value is going to stay the same, and your k value is going to be adding and subtracting the vertical difference, right? The vertical change. And then your foci are going to be even further within those direction of openings. So again, h value stays the same, and that'll be k plus or minus whatever that vertical distance is. Right? We usually call that c for the foci. So let's get right into it. First off, the equation that we need to know, general equation for a vertical hyperbola, will be y minus k squared over b squared minus x minus h squared over a squared equals 1. Alright, so looking at this, you'd say, alright, well, first off, we can see the h and k. Those are the numbers that are being added and subtracted to your x and y. Alright, but notice that it's minus h minus k, meaning you do the opposite sign of what you see. So if we have a plus 3 with the x's, you'll be doing minus 3. Right? There's nothing being added or subtracted to the y, so that's just 0. There you have it. So there is your h, there's your k. Now your vertices, alright, are going to be adding the vertical distance, and where we can see that is going to be in the denominator beneath your y, right? Y is vertical, so that means its denominator has the vertical distance. And that number we see is 16. So our b squared is 16, which if we undo that with the square root, we get b equals 4. Now, we're already doing plus or minus, so you don't need to worry about the plus or minus on the 4 there. Okay, likewise, we have a squared is 4. So I'm just going to write that one now. So a squared equals 4. So square root, right, both sides, we get a equals 2. So for those, then we'd say, all right, well, now we have for this one our h, negative 3. And then our k, which is our 0 plus or minus the b value we just found, 4. And those are your two coordinate points. Now we just got to simplify it. So we have negative 3 comma 0 plus 4, 4. And then negative 3 minus 4, so negative 4. There you go. Bam, vertices. Okay, your foci are really similar. It's negative 3 comma and then 0 plus or minus c. Now where that c comes from is what we call the Pythagorean relationship for hyperbolas, which is a squared plus b squared equals c squared. Alright, so for this one, you say, all right, well, we know a squared and b squared, right? That would be 4 and 16. So 4 plus 16 equals c squared. So in other words, 20 is c squared. Take the square root of both sides. We get c equals the square root of 20. Now remember, all answers simplified and exact. Don't you dare leave that square root unsimplified. That means that we break the 20 down. That'd be 4 and 5 is just an example of how to do that. Right? 4 is 2 and 2. You have two 2's, 5 left behind, so we have 2 square root 5 would be our c value. So it would be 0 plus or minus 2 square roots of 5. So that means your first focus point is negative 3 comma 2 square root 5. Because 0 plus 2 square root 5 is just 2 square root 5. Alright, your next one is going to be at negative 3 comma negative 2 square root 5. Because 0 minus the square root is the negative. Okay? There you go, and that is all of the information up top. Now all that's left is just graphing it. Now in order to graph, all you need is essentially your center, a, and b value. Okay, we just said that we had a vertical hyperbola, so on all of your graphing tools down below, make sure you're using the vertical hyperbola. Right, you don't want to use the horizontal one. Nope. Okay, you're using the vertical tool. Alright, so you'll notice that you have your center, right? And then you have your vertices, your co-vertices are over there. And then the red dot, the second point that you need is none of those. But that's okay, because all that red dot is it's an A distance over and a B distance, either up or down, right? That is all you need to graph the hyperbola there. So you'd say, okay, well, center is -3, 0. Bam! Okay, and then the second point you would need would be your A distance over, which we said was 2, so 1, 2, and your B distance either up or down, so 1, 2, 3, 4. If you graph that point, you will be correct. It will graph the hyperbola for you, and you're done. Okay, but what if you went down 4 instead? 1, 2, 3, 4. That's okay. If you chose your center, the black dot, and then that second blue dot went down instead, that would also graph the same hyperbola, right? You wouldn't have to worry about it, right? Even if you went left 2 and then up 4, or left 2 and down 4, either of those 4 main blue dots right there, okay, any of them will graph the hyperbola correctly. Okay, you just have to pick one of them. It's always going to be an A distance over and a B distance, either up or down. Okay? Now, if I'm going to briefly kind of just sketch this out for the remaining hyperbola, right? So our vertices are, going to be here and here, right? -3, 4, and -3, -4. Okay, and that means your co-vertices would have to be those ones right there, just as a fun fact. Okay, so if you draw your box and connect the edges, those will be your oblique asymptotes. And this is a very rough sketch, but it's fine. Okay, and then you go from your vertices closer to the asymptotes, but not actually crossing them. And this would briefly, vaguely look like your hyperbola for this equation. Rough sketch. Alright, that is it. Thank you so much for watching.